Welcome friends to this video. I'm Abhishek and today we are going to start this module. So before we start, let me introduce myself. I have done BTech in Mechanical Engineering from IIT Patna. Then I have worked as a design engineer for some time, and after that I went on to join a research program at IIT Bombay. And finally we started teaching online, and I have been teaching for almost 5 years as physics faculty, and good number of students I have mentored, and they are studying in various reputed institutions all across the world. And this year, I also got an opportunity to mentor one such student who ultimately went on to top JEE Main 2020 January attempt in outside India category. Okay, so with that, let us start. Today we are going to learn about motion. In this module, we will have a series of videos coming up and we'll be talking about motion. So we'll start with something called what is motion, and then we'll be moving on with the parameters which will help us to understand the motion better. Then what are the types of motion, then graphs, then equations of motion, motion under gravity after that, and finally we'll conclude this chapter with relative motion. So specifically we are going to talk about straight line motion only. Motion in one dimension is also what we call. So in a straight line, how does a body behave when it moves? What are the parameters involved, which will help us to analyze and understand the motion better? So all those things we are going to talk about in this. So let us start. So what do you understand by the word motion? So in simple words, if I say anything which is moving, or movement of any body or particle from one point to another, right? So let me write down movement of a body from one point to another. In simple words, this is how we say like motion is happening, right? That body is moving. Okay, now I'm going to take you to one such situation where this definition may not help us directly, and that situation is here in front of you. So there are two friends, A and B, and A is going somewhere and he's taking some luggage along with him, this box, and he's inside the bus, and B has just came to drop him and help him to board the bus, and A has boarded the bus and the bus started moving this way. And these two friends are very enthusiastic about physics, and they were very much interested in analyzing the motion of the box. So they got connected over a phone call and they started discussing about the motion of the box. And what they discussed is what I'm going to tell you. So Mr. A said that the box is not moving, it is at rest. But Mr. B said that no, it's moving. It's going away from me. Now my question to you is that who is right, who is wrong? You may pause the video and think about it for a minute. Okay, so let us discuss who is right, who is wrong. So actually both of them are right in their own perspectives. And that's where we have to understand that motion of a body is not absolute. It depends on the observer also. So that's why we need to redefine, or we should better our definition. Rather than just calling movement of a body from one point to another, we should make this definition better. And let me write down. We can say motion is a collective property because it depends on both observer as well as the body. It's a collective property of the observer and the body under observation. Simple. Motion is a collective property of the observer and the body under observation. We are talking about the motion of any body. How does it change with time? How does it change its position with time? So it depends on the observer's position also, that how observer is changing its position with respect to time. So it is quite possible that body is not at all changing its position, but the observer itself is going away or towards the body. So he may find it moving. So that's why it's completely a relative concept. Motion is completely a relative concept. That's why both of them in that particular example are correct. Both the friends are right. According to A, it's not moving without a doubt, because the separation between them is not increasing or decreasing. So how do we conclude? I mean, we humans are quite intelligent. How do we say that something is moving? We say something is moving only when we judge whether the distance from my position and the gap between myself and the object, is that changing? Is it increasing or is it decreasing? If it is not, we'll say, yeah, it's not moving. So in this case, the distance between A and B, sorry, not A and B, A and the box is not changing. So it's constant, it's fixed. So that's why it is like at rest with respect to A. A is saying it is not moving. He's right. But B is looking at the same box and he's measuring this distance. He's measuring this distance by just looking at it without any instrument. He's not going to take up a scale or something to measure this distance. And that is how he is concluding that this particular separation between the box and himself is increasing. So he's saying it's moving, it's going away. So that's the beauty of motion. That is how we define. So rest and motion are quite relative. So we never know who is moving, who is not in absolute sense. With that, I'll move forward to discuss those parameters which helps us to understand the motion better. So let me list them out. Those parameters are displacement and distance, and we have few more apart from these two, like the speed, velocity, acceleration, if we understand these five, we would be able to crack a lot of things about motion of a body. So let us start one by one. So I'll be discussing distance and displacement in this video, and rest of the things will be there in the upcoming videos. So distance and displacement. Many times students get confused that what is the difference. So let us discuss them one by one, side by side. So distance is defined as, it is the length of, distance is the length of the actual path traced by a moving body. Means the body has moved from one point to another and it must have traced certain path. We'll have some example after we define it. So it's the length, so we measure in meters. You can measure in any other unit also, but SI unit of length is meters. So distance would be measured in meters, standard unit. So this is how we define the distance. It is the length of the actual path traced by a moving body. That's it. Actual path, or whatever path it could be. Okay. It is the length of the actual path. So we have to draw the actual path from where to where body is going, and you have to measure the length of that path. Simple. That's it. What is displacement? It is the length of the shortest path connecting the initial and final positions. initial and final positions. That's it. Okay, means we will try to figure out what are the initial and final positions for that body. It must have started from somewhere, it must have stopped somewhere. So what are those 2 points which we call initial and final positions, or where the body was initially and where it is finally? So shortest path connecting initial and final position could be a straight line, nothing else. Like for example, a body is going something like this, let's say from here to here, and then it is taking a 90-degree turn and it's going over there. So let's say this starting point is A, it goes to C finally via point B. So it goes like this. So in this process you can see A is the initial point, initial position, and C is the final position. So if we try to find what is distance, so in this case the actual path is A to B and then B to C. So length of the line segment AB plus the length of line segment BC would be your distance, because that is the actual length of this path which has been traced by the body, because my body is going like this. Okay, it's tracing this path. So this is the actual path which the body is following. What about displacement? Displacement would be the shortest path possible between A and B. Possible in the sense, it should not be actually possible that you should have a connecting path from A to C. It may not be practically possible, but mathematically you have to think that what could be that path which would be connecting A to C, and it should be the smallest, and that could be simply a straight line. That's it. So A to C, there can be multiple paths which can connect A to C. Like this, I can choose one more path. It's reaching there. Okay, it's reaching there. I can have any other path also. It's again reaching there. So there are various paths which can connect A to C, but I need to choose the shortest, because that is what the displacement definition says. It is the length of the shortest path connecting the initial and final positions. That's it. So all I need to look for is that length AC. That's it. Okay. Straight length, straight line length. So line segment AC. So over here it would be AC, the length of line segment AC. That's it. So that's the displacement. So this is how we define distance and displacement, and this is how we find it. So if we take few values, we can solve it. Like let's say AB is 3 kilometers and BC is 4 kilometers. So you can see the distance is going to be 3 plus 4, that is 7 kilometers. And since this is a right angle triangle, displacement can also be found out by Pythagoras theorem. So AC is going to be like AC square will be AB square plus BC square. So AC square is equal to 3 square plus 4 square, which is going to be 9 plus 16, and ultimately I can add and take a root of that, square root. So 9 plus 16 is going to be 25. So square root of that is going to be 5. So that's the displacement. Thank you.